Asian and Pacific Island countries are facing increased vulnerability due to rapid population growth and economic development. Increased threats of natural disasters such as cyclones, floods and earthquakes are compelling risk-prone countries throughout this region to build and maintain resilience to such catastrophes. Sendai Framework for Disaster Risk Reduction has identified the significant role that space-based technology (SBT) and information communication technology (ICT) can play to reduce vulnerabilities and improve resilience. By integrating SBT and ICT tools with National Disaster Risk Management Architecture, timely and accurate information can be delivered to relevant communities, individuals, rescuers and decision makers to save lives and properties at risk. The Asian Development Bank has initiated a technical assistance project for risk-prone countries to strengthen their resilience by applying SBT and ICT tools. The project is funded by the Japan Fund for Poverty Reduction with technical assistance from the Japan Aerospace Exploration Agency, and implementation is led by the Geoinformatics Center at the Asian Institute of Technology. Partners include Asian Disaster Reduction Center, Remote Sensing Technology Center, and GeoThings. Pilot areas in 4 countries, Armenia, Bangladesh, the Philippines, and Fiji, have been selected for this project. In order to accomplish this, 2 mobile applications, GeoMap Tool and GeoBingN, have been developed along with data viewing software GeoBingN Web. The whole process is completed in 5 steps. 1. Local communities digitize roads and buildings on OpenStreetMap, which is a global open source map of the world. 2. The base map is created by a local community by adding building attributes to the map, such as building condition, height, and building material by using GeoMap Tool during the field visits. 3. With the help of DRM specialists, communities geo-record disaster capacities and vulnerabilities by using GeoBingN app. This information is visualized to create community hazard maps using GeoBingN Web. 4. During the disaster, GeoBingN allows the user to record information including disaster situation, building damage, and needs assessment using simple drop-down menus to create a report in an offline environment. These reports can be viewed on GeoBingN Web by the government officials in order to make timely decisions by providing near real-time data from the field. 5. Upon the request of National Disaster Risk Management Officers, emergency observation from satellite data can be acquired. This powerful data allows governments to understand the extent of a disaster. When it is overlaid with community-based maps, damage extents can be estimated. In Fiji, the project is implemented by the Ministry of Rural and Maritime Development and National Disaster Management. Nadi town was chosen for the project as it is prone to flooding, cyclones, and earthquakes. The project focused on 3 villages, Namotomoto, Nawaka, and Saunaka. In Nadi, over 5,000 buildings were digitized in OpenStreetMap by volunteers. By using GeoMap Tool, the same volunteers were able to add more detailed information such as roof material, building type, and more to over 2,000 buildings. Local volunteers under the supervision of a DRM specialist used GeoBingN app to record vulnerabilities and capacities in these villages relating to floods and cyclones. Volunteers were successfully trained to use these new ICT tools, demonstrating the potential of their usage for community-level DRR. Using the GeoBingN Web, recorded vulnerabilities and capacities are used to create community-based hazard and evacuation maps. These maps are used to identify safe zones for village members to seek shelter and identify hazard areas for DRR planning. The project culminates with local villagers being trained to use SBT and ICT tools to collect crisis mapping information like situational reports, needs assessment and damage reports to improve data resilience.